Hello and welcome to the harmful electromagnetic waves revision video from scienceworksheets.co.uk. Please like, subscribe and comment to support the channel. Some types of electromagnetic waves can cause us harm or be hazardous to our health. The effects of the radiation depend on the type of radiation and the size of the dose. So looking at the electromagnetic spectrum, as the energy increases, the electromagnetic waves become more harmful, and in particular ultraviolet, X-rays and gamma rays are all known as ionizing forms of radiation. Ionizing radiation, ultraviolet, X-rays and gamma rays are all forms of ionizing radiation. This means they have enough energy to knock electrons off of atoms to form ions. And in the diagram you can see the electromagnetic radiation acts on the atom and the electron is lost, and so an ion is formed. Harmful effects of ultraviolet radiation. Short-term exposure to ultraviolet radiation can cause sunburn and aging of the skin. Long-term exposure to ultraviolet radiation can cause mutations, which is changes to the DNA, which increases the risk of developing skin cancer. And ultraviolet radiation can damage the retina, which is at the back of our eyes. Harmful effects of X-rays. X-rays are ionizing forms of radiation, so when our bodies are exposed to X-rays, there is a slight increased risk of cancer. However, the risk is tiny. X-rays penetrate the body, so they can damage the DNA in our cells. But the benefits of an X-ray will often outweigh the risks. Harmful effects of gamma rays. Gamma rays are ionizing forms of radiation. These also carry the most amount of energy of all the electromagnetic waves. Gamma rays are highly penetrating, so they easily pass through the human body. And gamma rays are used by doctors to kill cancer cells. This is known as radiotherapy. However, the gamma rays can also harm or kill healthy cells. When healthy cells are exposed to gamma rays, the gamma rays can cause DNA mutations which increase the chance of cancer. Sieverts is a measure of radiation dose to indicate the risk of harm resulting from an exposure of the body to the radiation. 1 sievert is a very large dose, so most exposures are based on millisieverts as shown in the table below. So a typical chest X-ray will be about 0.1 millisieverts. Typical annual background radiation is about 2.4 millisieverts. Thank you for watching. See our revision notes on this topic. The link is in the description.